Hello, my dear friends. How are you all? I hope you all are fine. So, my dear friends, you are very welcome in a lecture number 4 of probability. Okay. So, this lecture is going to be very amazing because in this today we are going to discuss. Yes. So now today we are going to discuss some special events part 1. Okay. So this is the part 1 of special events. So in this lecture we are going to discuss some special events like we are talking about the cards. Okay, and we are talking about the tossing a coin two times, okay, and rolling a dice two times. Okay, so there are some special events which is very useful, and you have to be learn about these events. Okay, so now let's start without wasting the time. We are going to discuss first of all the cards. Okay, now we know that we already learned in the previous lectures about the cards. Okay, and here we are going to discuss different questions on the cards. Okay, I hope you understand these things, my dear friend. So here we know that there are total 52 cards. There are total 52 cards. Okay, and these 52 cards are divided into two parts. Are divided into two main parts, which is red cards and black cards. Red cards and black cards. Okay, two most important cards are what? Red cards and black cards, like this. Red cards and black cards. Okay, now red cards and black cards are also divided into different categories, like red cards. Okay, in red cards there are total 26 cards. Okay, and in black cards there are total 26 cards, same. Okay, and in red cards it is also divided into two parts, like heart and diamond. Heart and diamond. The symbol of heart is like this, and the symbol of heart is like this. Okay, I hope you get this point, my dear friend. Now in hearts there are again 13 cards, and in diamonds there are 13 cards also. Okay, I hope you get this point. Now black cards are also divided into two parts, means spades and clubs. Spades and clubs, like this is our spades, this is our clubs. This is spade and this is club. This is heart and this is our diamond. I hope you get this point. Now in spade there are 13 cards, and in clubs also there are 13 cards. Now my dear fans, now we have four categories: hearts, diamonds, spades and clubs. Now heart is also divided into two parts. Okay, so it is divided into honor cards, okay, and the digits cards. In honor cards there are four main cards. There are four main cards, okay, and rest of the 9 cards are the digits cards. Okay, and similarly diamond is also divided into two categories, like honor card and digits cards. Okay, and spades spades are also divided into two categories, like honor card and digits cards. Clubs is also divided into honor cards and digits cards. Okay, got it. Now what is honor card? So in honor cards there are four main cards. Okay, so we can write here as is, king, queen and jack. So these four cards are called honor cards. Okay, so these four cards are the honor cards. Okay, now there is one more thing, which is face cards. Okay, so now if you talk about just only king, queen and jack, king, queen and jack, these three cards are called the face cards. Are called the what? These are the face cards. So we can write here as king, queen and jack. These three cards are called face cards are called face cards. Okay, I hope you get this point. Now you can see in this. Okay, similarly we have heart, diamond, spades, clubs and spades. Okay, and in this, in heart there are 13 cards. There are 13 cards. Which are these? First three are face cards, means king, queen and jack. Okay, and the fourth one is ace. And if we join these four cards, this is our honor cards. This is our what? Honor cards. Okay, and rest of these cards are digit cards. These are what? These are digit cards. Okay, means 2 3 4 5 6 7 8 9 10. Okay, so I hope you understand these things, my dear friend. So similarly in diamonds there is also king, queen and jack, and one is ace. Okay, now these three cards are called face cards. Okay, so face cards are present in all the categories. Okay, and one ace is present in all the categories, and rest of the digit cards are present in all the categories. Okay, I hope you understand these things, my dear friend. Similarly clubs is also divided into face cards and the digits cards, and one is the ace. Okay, now similarly these spades are also. So I hope you understand these things. I hope you understand the concept of cards. Okay, so now we are going to discuss the problem based on the cards. Okay, so for solving these cards, for solving the problem based on the cards, you have to learn these table. You have to learn this table. Okay, so this is very important part of these cards. So now, yes, now the question number 1 is, from a normal pack of cards, a card is drawn at random. We are drawing a card randomly. Now find the probability of getting a jack or a king. A jack or a king. Okay. So now there are 4 kings and 4 jacks in a standard 52 cards. We know that in 52 cards, we know that there are 4 jack and 4 king cards. Okay, I hope you get this point. So there are total cards are also, we can write here as total sample space, means total favorable outcomes we can write as 4 plus 4 is what? Is 8. Okay, and total outcome is what? We know that there is 52. Okay, so from this we can say that 1 2 3 and 4, 4 kings and 1 2 3 and 4, means 4 jack, means there are total 8 cards. So we have to draw a card from the 52 cards. Okay, now we have to find the probability of getting a jack or a king. Okay, and we know that there are total 4 jack and 4 king. So total favorable outcome is 8 and total outcome is 52. Okay, so now my dear friends, probability of getting jack or king. So this is equals to 8 upon 52. So this will be, if we solving this, we get 2 upon 13. So this is the correct answer. Okay, I hope you understand these things. So now let's move on. Yeah, so the next question is, my dear friends, here is, a card is drawn at random from a pack of well shuffled 52 cards. Okay, pack of well shuffled 52 cards. Now what is the probability of getting a queen of red? Okay, so now my dear friends, we have, here is, there are 2 queen, there are two queen of red. Okay, if we see in the diagram, in this diagram, so we have queen is this one and this one, and the total number of red cards are 26. Okay, so here we can write total red cards are what? 52 cards. Okay, so here we can write favorable outcome is 2 and total outcomes is 52. Okay, so we can find the probability of getting a queen. So this is equals to 2 upon 52. This is equals to what? 2 upon 52. And if we solve this, we get 1 upon 26. Okay, what is 1 upon 26? So this is our required answer. This is our required answer. I hope you understand these things, my dear friends. So now let's move on. Yes, so the next question is, my dear friends, here is, now again a card is drawn at a random from a pack of well shuffled 52 cards. Now what is the probability of getting a face card? Okay, now in this case we have to find the probability of getting a face cards. Okay, we know that how many face cards are, so the total face cards are, here is 3, 3, 3 and 3, means there are total 12 face cards. So we can write here is there are 12 face cards okay, in 52 cards, 52 deck of cards. Okay, now my dear friends, favorable outcomes is 12 and total outcomes is 52. So we can find probability of getting a face card. Probability of getting a face card. So this is equals to 12 upon 52. This is equals to what? 12 upon 52. Okay, after solving this, we get 3 upon 13. What is? Yes, 3 upon 13. So this is the required answer. Okay, I hope you understand these things. So now, my dear friends, let's come on the new event which is based on the coins. Okay, so there are different events. Okay, like if when we toss a single coin. Okay, now when we toss a coin 2 times, when we toss a coin 3 times, so there are different sample space in different events. Okay, so now in the first case, when we toss a coin 1 time, in this case the sample space is what? The sample space is head and tail. Sample space is head or tail. Okay, now in the second case, when we toss a coin 2 times, then in that case the sample space are head or head tail or tail head or tail. Means either both the times head is come. Okay, now in this case, one time the head is come and the second time the tail is come. Now in this case, in the first time the tail is come and in the second time the head is come. In this, both the times tail is come. Okay, so these are the what? These are the sample space. These are the sample space. Okay, now if we see the third case, now in the third case, when we tossed a coin 3 times. Now in this case, my dear friend, the sample space are here is, so total possible outcomes or sample space are had, tell, had, tell, had, tell, had, tell, had, and the last is had, tell. So these are the sample space. These are the what? Sample space. In this, there are 2 sample space. In this, there are 4 sample space. And in this, how many space? How many sample space? 1, 2, 3, 4, 5, 6, and 7, 8. So there are 8 sample space. What is? So there are 8 sample space. So similarly, we can find the sample space of the when we toss a coins greater than 3 times. Greater than 3 times. Okay. So how we can find the total number of outcomes in different cases? Now the total number of outcomes can be calculated as the total number of outcomes can be calculated as 2 raised to power n. N is what? N is the number of times the coin is tossed. Okay, N is what? Here N is number of times the coin is tossed. Okay, so my dear friends, if let's suppose n is equals to 1, then total outcomes is what? Total outcomes is 2 raised to power 1 means 2. Here you can see that if we toss a coin 1 time, then the total number of outcomes is 2. Now if n is equals to 2, then total outcomes is 2 raised to power 2 means this will be 4. So we can see that here as if we toss a coin 2 times, then the total number of outcomes is 4. Okay, now if we put n is equals to 3, then we get total outcomes is 2 raised to power 3. So this will become 8. Now you can see in the third case, so total outcome is what? 8 when we toss a coin 3 times. Now when we toss a coin 4 times, then in this case total number of outcomes is 2 raised to power 4. 2 raised to power 4, so this will be 16. This will be what? 16. So I hope you understand these things. So now we can find similarly and so on. We can find for n is equals to 4, n is equals to 5, 6, 7, and so on. Okay, I hope you understand these things, my dear friends. So now let's solve some problems based on these events. Yes. So the question number 1 is 2 different coins are tossed randomly. Okay, we are tossing the 2 different coins. Now we have to find the probability of, first is getting 2 heads. First is what? Getting 2 heads. So first of all, we have to find the sample space. So what is the sample space? Had, tell, had, and tell. So total number of outcomes is 4. Okay, now in this case getting 2 heads. Okay, so in this case the favorable outcomes is like getting 2 heads. It means just one case means favorable outcome is what? The favorable outcome is just 1, because favorable sample space is had. Okay, the two heads are come when the both the times head is come. So we have favorable outcome is 1 and total outcome is 4. So the probability of getting two heads is equals to 1 upon 4. What is 1 upon 4? So I hope you understand these things, my dear friends. So now let's move on. Now we have to find the probability of getting two tails. Means getting two tails. So now again in this case, favorable outcome is again 1, because if you see this, the condition of two tail is just once. So here is 1 and total outcomes is what? We have total outcome is 4. So again the probability of getting two tails, this will be again 1 by 4. This is the answer. Now getting one tail. Now getting one tail. So one tail, the cases are, the favorable outcomes are, here you can see that getting one tail means this is the case and this may be the case. So here is favorable outcomes are tail head or head tail. So this is 2, and we know that total outcomes is 4. So the probability of getting one tail, so this will be what? This will be 2 upon 4. So this is equals to 1 by 2. So this is the answer. I hope you getting this point, my dear friends. So now here is, now getting no head. So this is, in this condition, favorable outcomes. When there is no head, then there will be tail, means the condition is tail tail, means favorable outcomes is 1 and total outcomes is 4. So we can find the probability of getting no head. This will be 1 by 4. This will be what? This will be 1 by 4. Okay, now getting no tail means if there is no tail, then what will be? Then there will be head. Okay, in this there is no tail. So again this is 1, favorable outcome is 1 and total outcome is, yes, total outcome is 4. So we can find probability of getting no tail. So this will be 1 by 4. This will be what? 1 by 4. Okay. So now in this case we have to find the probability of getting at least one head. Okay. So now favorable outcomes are at least one head, means the cases are head tail and tail head. So these are the cases. So how many cases? There are 3 cases. Okay. So total outcomes is 4 and we can find the probability of getting at least one head. So the result is 3 upon 4. So this is the answer. Okay. Now getting at least one tail means in this case favorable outcomes are at least one tail, means the cases may be head tail, the case may be tail head, and this may be tail tail. So in this case, how many favorable outcomes? Again there are 3 favorable outcomes. So total outcomes is 4. So we can find probability of getting at least one tail. So this will be 3 upon 4. So this is the answer. 3 upon 4. I hope you understand these things, my dear friends. So now here is, now getting at most one tail. At most one tail. It is saying that you have to focus on the word at most. Okay. So now we have to find the probability of getting at most one tail. So So now the at most means maximum one tail. Okay, there is not more than one tail. Okay, so here is favorable outcomes are, here is had tail had. Okay, and it should be had. Okay, there is no tail. Okay, and maximum one tail. Okay, so how many outcomes? So there are favorable outcomes are 3 and total outcomes are, what is total outcomes? 4. Okay, I hope you're getting this point, my dear friend. So now here is the result is what? The probability of getting at most one tail. Okay, so this will be 3 upon 4. This is the correct answer. Okay, now getting one head and one tail. Getting one head and one tail. So in this case, the favorable outcomes is this may be the case or this may be the case. Had tail or tail had. So favorable outcomes is, total number of favorable outcomes is 2 and total outcomes is 4. The result will be probability of getting one head and one tail will be 2 upon 4. What is 2 upon 4? If we're solving this, we get 1 upon 2. So this is the result. Okay, I hope you understand these things, my dear friends. Okay, so now let's move on. Yes, now when 3 unbiased coins are tossed once, unbiased means, here is, means we are using fair coins. We are using what? Fair coins. Okay, and we are using a fair coins and we are tossing a coins 3 times, means 3 unbiased coins. Okay, now we have to find the probability of, first is getting all tails. So first of all we have to write the sample space. What? Yeah, first of all we have to write the sample space. Now what are the sample space? So these are had, tail. Okay, now one time had, second time tail, and third time tail. Okay, next is tail had, tail had, tail had, tail had, and had tail. So you have to be learn these sample space. Okay, so now in this, what is the favorable outcome? So if you observe this, favorable outcome is, we have to find the probability of getting all tails. Okay, so there is a just one case for all tails. Okay, so we can write here tail, tail, tail. So this is just only one case. So and we know that total outcome is 1 2 3 4 5 6 7 8. Okay, I hope you get this point. So now, my dear friends, the probability of getting all tails is what? Is 1 upon 8. What is 1 upon 8? So I hope you understand these things, my dear friend. Yes, so now next is getting two hats. Okay, so for this, what is the favorable outcome? So if you observe this, in this case you can see that 2 had means, here is the case is, this is the case, here is 2 hats, in this 2 had is also, in this there is 2 had. Okay, so we have had tail, had tail, had. Okay, and tail had. So these are the conditions, so these are the cases. So how many favorable outcomes? There are 3 favorable outcomes. What is? Yeah, there are 3 favorable outcomes and we know that total outcomes is 8. So we can find probability of getting 2 heads. Probability of getting 2 heads is what? 3 upon 8. Favorable outcomes upon total outcomes. So this is the correct answer. This is what? This is the correct answer. So I hope you understand these things, my dear friends. Now the second case is getting at least 1 head. So the favorable outcomes in this case. Now here is getting at least 1 head. So in all the cases there is headed except this case. In all the cases there are head except this case. All tails. So now the favorable outcomes are head, tail, tail, head, tail, head, 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 tail, head, and head, tail. So these are the cases. I hope you get this point. So how many cases are there? So they are, you can count this, 1, 2, 3, 4, 5, 6, 7. So there are 7 cases. And we know that total outcomes is what? Total outcome is 8. So we can find probability of getting at least 1 head. So what will be? So the answer is 7 upon 8. 7 upon 8. So the chances of getting at least 1 head is what? 7 upon 8. I hope you get this point. Now the next is now getting 1 head. So the cases are for getting 1 head is favorable outcomes are, you can see in the sample space, what are the cases? This is the cases. In this there is just only 1 head. There is only 1 head and there is only 1 head. So head, tail, head, tail, head. Okay. So the cases are head, tail, head, tail, head. Okay. Understand? And how many? There are 3 total favorable outcomes. Okay. So total outcomes, we know that 8. What is 8? So here we can say that probability of getting 1 head is 3 upon 8. What is 3 upon 8? Understand, my dear friends? Okay. Yes. So now let's move on. Yes. So now we are going to solve the problems based on the dice. Okay. So now again, there is a different cases to there are different cases in the dice. Okay. So here is now the case 1 is if we roll dice once, means if we roll the dice 1 time, we roll the dice 1 time. So in this case the sample space are simple. We know that 1, 2, 3, 4, 5 and 6. So there are simple sample space. So the total outcomes is what? Yeah, 6. Okay. So now based on the sample space we can easily find the problems based on this case. Now the second case is very important. Second case is when we roll a dice 2 time. Or we can say that when we roll 2 dice at a time. So both the conditions are same. Sample space for both the conditions are same. When we roll a dice 2 times or when we roll 2 dice at a time. Okay, so the sample spaces are same in both the condition. Now what are the sample spaces? Let's see. Yes, in this case the sample space here is. Now first is 1 comma 1, second is 1 comma 2. Means the meaning of this is, on the one dice, when we roll 2 dice at a time, the on the one dice there is 1 come, and on the another dice there is 1 come. Now in this case, on the first dice 1 is come, and on the second dice 2 is come. Okay, now similarly 1 3, this is also the sample space. 1 4, 1 5, and here is 1 comma 6. Okay, similarly here is 2 comma 1, this may be the chances. Here is 2 comma 2, 2 comma 3, 2 comma 4, 2 comma 5, 2 comma 6. I hope you get this point. Now this will be 3 comma 1, 3 comma 2, 3 comma 3, 3 comma 4, 3 comma 5, and 3 comma 6. Now same 4 comma 1, 4 comma 2, 4 comma 3, 4 comma 4, 4 comma 5, and 4 comma 6. And 5 comma 1, 5 comma 2, 5 comma 3, 5 comma 4. Here is 5 comma 5, 5 comma 5, and 5 comma 6. And the last row is 6 comma 1, 6 comma 2, 6 comma 3, 6 comma 4, 6 comma 5, and 6 comma 6. So these are the sample spaces. These are what? They are the sample spaces. And total outcomes is what? There are 6 cases in first row, and similarly we have 6 rows. So we get 6 into 6 means 36 cases. So total outcomes is what? Total outcomes is 36. Okay, I hope you get this point, my dear friends. So now with the help of these sample spaces we are going to solve the problems. Okay, so what are these? Yeah, so the problems are, now what is the probability of getting a prime number in a throw of a die? Here we are going to roll or throw a single die. So now the sample space are what? 1 2 3 4 5 and 6. Okay, now here is favorable outcomes is, you can see that we have to find the probability for the prime numbers. Now what are the prime numbers? So my dear friend, the prime numbers are, here you can see that 2, 3, and 5. So these are the prime number, and total number of favorable outcomes is 3, and we know that total outcomes is 6. So what is the probability? So my dear friends, probability of getting a prime number is equals to favorable outcomes upon total outcomes. Now what is favorable outcomes? This 3. And what is total outcomes? This is 6. So if you solve this we get 1 upon 2. What is, my dear friends? 1 upon 2. So this is our correct answer. Okay, yes. So now, yeah, so the next question is, when 2 dice are thrown, what is the probability of always getting a number greater than 4 on the second dice? Okay, I hope you get this point. So now here is favorable outcomes are what? Now you can see in these sample spaces on the second time, means on the second dice, here is, now we have to find those favorable outcomes, those favorable cases in which there is a number greater than 4 on the second dice. So here we can see that if you see 1 comma 5, this is correct, are favorable outcomes. Similarly, this is correct. This is 2 comma 5, 2 comma 6, 3 comma 5, 3 comma 6, 4 comma 5, 4 comma 6, 5 comma 5, 5 comma 6, 6 comma 5, 6 comma 6. So total how many favorable outcomes? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. How many? So we can write here 12, and we know that total outcomes is what? Total outcomes we have 36. So now from this we can find the probability of getting a number greater than 4 on the second dice. So what is the answer? We know that favorable outcomes divided by total outcomes. So this will be 12 upon 36. If we solving this, we get 1 upon 3. What is 1 upon 3? So this is the correct answer. I hope you understand these things, my dear friends. Yes. Yes. So the next question is, my dear friends, here is 2 dice are thrown at a time. What is the probability that the difference of the number shown on the dice is 1? Okay, so now in this case, favorable outcomes are, here is, you can see that, my dear friends, in the sample space. Okay, in this case, in the sample space, you can see that here is, now the difference between, what is difference of the number shown on the dice is 1. Okay, if we see that here is, now the difference in between these two numbers is what? 2 minus 1 is 1. This is the sample space. 2 and 3, here is again we can say that the difference is 1, and this is also again the difference is 1. Okay, in this case there are two, favorable outcomes, and now in this row we have 3 comma 2. Okay, we have 3 comma 2. If we take the difference between these two numbers, we get 1, and we have 3 comma 4. Okay, now in this case we have 4 comma 3 and 4 comma 5. Okay, and in this row 4 comma 5 comma 4 and 5 comma 6. Okay, and in this case, in this row we have just only one case, 6 comma 5. So we have total number of favorable outcomes is what? 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. 8, 9 and 10. So we can write here as, favorable outcomes are 1 comma 2 and 2 comma 1. Okay, and here is 2 comma 3 and 3 comma 2. Okay, and 3 comma 4 and 4 comma 3, and 4 comma 5 and 5 comma 4. Okay, and here is 5 comma 6. Okay, and 6 comma 5. I hope you get this point, my dear friends. So these are the favorable outcomes. And how many favorable outcomes? So they are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So total number of favorable outcomes are 10. Okay, now total outcomes we know that 36. So we can find the probability of getting the number probability getting the number that the difference of the number shown on the dice is 1. Okay, so what is the probability? So the probability is 10 upon 36. What is 10 upon 36? And if we solve this, we get 5 upon 18, because we can cancel it both the numerator and denominator by 2. Okay, so we get 5 upon 18. So this is the correct answer. This is what? Yes, this is the correct answer. Okay, so now, so the next question is, my dear friends, in a single throw of a dice, what is the probability of getting a sum of 10? So my dear friends, okay, in the throw of a 2 dice, okay, we know that the sample is space. Okay, now it is saying that what is the probability of getting a sum of 10? Okay, yes, so here is, my dear friends, so first of all we have to write the favorable outcomes. So what are the favorable outcomes? So if on the first dice there is a number 5, and on the another dice there is also a number 5, so this is the case of the favorable outcome, because if we add 5 plus 5, we get what? We get 10. Okay, now the next case will be 4, 6. Okay, if we add these two numbers, we get what? We get 10. And the another case will be 6, what is 6, 4. Okay, so these are the favorable outcomes. These are the favorable outcomes. And how many? So they are 1, 2 and 3. So there are 3 favorable outcomes. So here is, we know that total outcome is what? Total outcome is, we can write here as 36. So we can find easily probability of getting a sum of 10. So this will be 3 upon 36. After solving this, we get 1 upon 12. So this is the correct answer. This is what? This is the correct answer. So I hope you understand these things, my dear friends. So so now, my dear friends, this is enough for today, and we will meet in the next lecture with the next amazing topic. So thank you very much for listening me, and take care and goodbye.